This is a video series about really understanding computer code and becoming an actual programmer. It's for people who know how to write small programs using basic language features like variables, lists, print statements, if statements, and loops, and who have probably watched a number of programming tutorials, but who still have trouble knowing where to start when it comes to writing a program from scratch. We'll use Python in this version of the video. If you want to see it done in JavaScript or C++, there are separate videos that are the same as this one, but using those languages. It's a great learning experience to see a problem solved in multiple languages. You'll find that programming languages are more alike than different. When you know one or two programming languages, you kind of know them all in a fundamental sense. Along the way, we'll build up a set of mini patterns that I call pro tips, which are principles or rules of thumb that can be used in solving a wide variety of problems in any programming language. Let's start with a program that inputs a number and prints a pyramid of stars. It's a terminal program, so if we type python pyramid.py and press enter, it asks us how many rows in our pyramid. So if we enter 4 and press enter, the program prints a 4-row pyramid of asterisks. If we input 2, it prints a 2-row pyramid, and if we input 6, it prints a 6-row pyramid, and so on. Let's put the output with 4 rows on the side here so we can refer to it as we work on this problem. Now, you might already have some programming experience, and you might be able to write this program straight off. In fact, whatever your programming level, you might want to pause the video and see if you already know enough to solve this problem. Now, if this were a typical tutorial, I could calmly write out a solution with a bit of explanation as I go. But let's suppose we don't know the solution right away. How do we start? Well, we have to print n lines, whatever the user input n is. So it seems like we're going to need a loop. And each time through the loop, we'll print a line. Looking at the output, we can see a pattern. Each line has a certain number of spaces followed by a certain number of stars. Each line has 2 more stars than the line before it. As for the spaces, the first line starts with 3 spaces, and the spaces are reduced by 1 for each subsequent line, till there are 0 spaces on the last line. So we have a growing number of stars and a decreasing number of spaces. We have a loop, and recall that loops using the range function, and most computer loops in general, count from 0 to the number -1. Like if the input n is 4, the I in our loop would be 0 the first time through the loop, then 1, then 2, then 3, then the loop is done. So it seems like we have to come up with some formula, some code expressions, to convert our loop counter I into a number of spaces and a number of stars. But it might not be immediately clear what the formula is. We might feel overwhelmed having to come up with code that will not only compute the right values, but will also generate the output, the actual spaces and stars to print on the screen. Now, we might be tempted just to guess at some expressions involving I and n, like I plus 1 or I minus 1, 2 times I, n minus 1, n minus 1 minus I, n minus 2 times I, or something like that. And then tweak the code, adding or subtracting 1 here or there until we get the right output. We might think a real programmer would just know these expressions, but I can only guess at them. Well, to make ourselves feel better, we can introduce our first pro tip. Solving a simpler problem can sometimes bring you closer to a solution, or at least help you understand the problem better. So how can we make this problem simpler? How about if we printed just the stars and didn't worry about the spaces? Or actually, what if we just printed 1 star on each line? Now that we know how to do. We just print 1 star each time through our loop. Okay, let's run the code. We input 4 rows, and there we go. We printed 4 lines with 1 star on each line. A small victory, but we'll take it. Now how can we print the right number of stars on each row? The truth is that even an experienced programmer would have to stop and think for a bit about how to compute the right number of stars from the loop counter I. The programmer makes a table like this in his or her head, with special focus on the first time through the loop when I is 0. We can see that the first time through the loop when I is 0, we want to print 1 star. And each time through the loop, we want to print 2 more stars. So somewhere in there, it seems like we need I times 2. But if we just multiplied I times 2, we'd get 0, 2, 4, 6 stars. Those are all 1 less than the desired values. So if we add 1, then let's see. For I equals 0, we get 0 times 0 is 0, plus 1 equals 1. That's good. For I equals 1, we get 1 times 2 equals 2, plus 1 equals 3. That's good. For I equals 2, we get 2 times 2 equals 4, plus 1 equals 5. And for I equals 3, we get 3 times 2 equals 6, plus 1 equals 7. Great. That expression seems to work. Let's put it into our code. Okay, so now we know how many stars we need to print. But how do we actually print that many stars? It turns out Python has a little shortcut for this, where you can multiply a string by a number in order to repeat the string that many times. For example, if we multiply the string hello by 3, we get hello, hello, hello. So it's a bit of a trick or convenience that Python allows us to multiply a string times a number. Now JavaScript and C++ don't have built in the exact same string multiplication trick. So as an exercise, let's pretend we didn't know about the string multiplication in Python. We have the right value in our variable num stars. How can we print a line with that many stars? Well, we know about using loops to repeat things, so let's put a subloop inside our main loop. Okay, let's run it. We input 4, and yikes, that's a lot of lines. What happened? Let's stare at the code. So what does the Python print function actually do? It prints some text and then a new line character. That makes sense because looking back at our single star version, each asterisk was printed on its own line. There are a few ways out of this problem with the new line character, but in this case, looking up the documentation for the print function, we see there's an option to pass an end parameter to print. And if we specify end equals empty string, it means to print nothing at the end. No new line, no nothing. So let's put that in. Okay, we run again. We input 4. Darn, now we have the other extreme. Everything came out on one line. Let's stare at the code again. So the use of end equals empty string was good in terms of getting all the stars to come out together on one line. But after we print the stars for each line, we need to print a new line at the end of the line. We can do that by putting a print nothing statement after our inner loop. Printing nothing means just to print a new line character, because all print statements print a new line character at the end, unless they have that end equals empty string parameter. Okay, let's run it one more time. We input 4. Yes, we got it. It's great that we went through the exercise of using a subloop to print a line of stars. But for Python in particular, the string multiplication operator is available, so let's use it. It replaces the subloop and also gets us out of having to worry about the end equals empty string parameter with print. There we go. That does look much simpler. And we'll just test it again to make sure it still works. Yes, it looks good. So we're close to the solution of this pyramid problem. We just need to print the right number of spaces before each row of stars. We found a formula for the number of stars using a table. Let's add a spaces column to the table with the heading S. When I is 0, we need 3 spaces, at least for our sample 4-row pyramid. Then each subsequent row has 1 fewer space. Again, the key is to focus on that first row where I is 0. For our 4-row example, the first row has 3 spaces. And with a bit of thought, we can see that the number of spaces for the first row is always n-1. That way, we always get down to 0 spaces on the last row of the pyramid. Here, it's 4 minus 1, and if we were making a 5-row pyramid, we would need to start with 4 spaces, which is 5 minus 1. So let's start our expression as num spaces equals n minus 1. Then, as our loop continues and I increases, we need to subtract spaces, subtracting 1 when I is 1, 2 when I is 2, and so on. Which means we always want to subtract I from our initial n minus 1. Yes, that expression seems to work for the number of spaces. Let's put it in the code. We can easily extend our print statement to print the spaces before the stars for each row. Let's see how it works. Run the program, input 4 rows. It works. That's great, but we should always check that our code works with a range of inputs. Let's try 5 rows. Looks good. Let's try 2 rows. Yep, that looks good. Okay, let's try 1 row. That's right, it prints just the 1 star. And let's try 0 rows. That's right, that's what we expect, it prints nothing. Okay, let's try 15 rows. Yep, that looks good too. I'd say the code is working. We've completed the program, but there's something about this solution that bothers me. As you gain more experience in programming, you develop an inner voice, an inner critic, who tells you that even though your code may be working, it could be improved. In this case, the voice is telling us that these 2 expressions we wrote for the number of spaces and number of stars took us a bit of time to work out. And if it was tricky for us to think of them, it's going to be tricky for someone else to understand this code later. These aren't the most complicated expressions in the world, but at least for me, when I look at them, I have to kind of stop and think to remind myself how they work. Now, we can put in comments explaining how we got the expressions. That helps a bit, and it will remind us what we were thinking. But it adds wordiness, and it doesn't really change the fact that we have to stop and think about these expressions in the first place. In fact, let's capture this as a pro tip. Code that's tricky to write is tricky to maintain. And if you need a comment to explain code, see if you can simplify the code so the comment isn't needed. Let's step back and think about whether we can solve this problem without these somewhat complicated expressions. Let's stare at the code. The answer is that we can use variables to keep track of how many spaces and stars a line should have, instead of recomputing the values each time through the loop. We start the variables at appropriate values, and then we modify them each time through the loop. So before the loop, let's start our variable num stars at 1, since the first pyramid line always has 1 star. And let's start our variable num spaces at n minus 1, because the first line always has n minus 1 spaces, as we just saw. Then in our loop, we simply print num spaces spaces followed by num stars stars, and then we change the variables to prepare for the next time through the loop. So we add 2 stars and subtract 1 space. And this all replaces our 2 complicated expressions, which makes our inner code critic happy. Okay, let's see if it all still works the same. Input 4 rows, and there it works. And let's try 2 again. Looks good. And let's try 5 again. Looks good. The code is easier to read without those expressions, and in fact we can win a style point by changing our loop variable to an underscore. This is a Python convention, which means we no longer care about the loop variable because we're no longer computing anything with it inside the loop. We can also state what we did here as a pro tip. There's often a choice between using state variables or computing from scratch each time. Counter variables like num spaces and num stars, as used here, are an example of state variables, because they keep track of the state of the program. As we saw, state variables can lead to simpler code, because we just modify them as we go instead of recomputing them from scratch. The downside is that if a state variable gets messed up, like if you mistakenly increment a state variable somewhere in your code, the entire run can get out of sync without an easy way to get back on track. Thank you for accompanying me on this problem-solving journey. But remember, you become an actual programmer through practice by writing your own programs. So here are 4 exercises for you to try that reinforce the concepts we covered in this video. You'll also find these exercises in the comments below. Exercise 1, block.py. Write a program that inputs a number and prints a solid block of stars, just like that. Exercise 2, square.py. Write a program that inputs a number and prints a hollow square of stars, just like that. Exercise 3. Write a program rectangle.py that inputs 2 numbers and prints a hollow rectangle of stars with the given width and height, 4 and 6 in that example. Exercise 4. Input a number and print a hollow inverted pyramid with that many rows. Yes, this one's a bit more challenging, but you could start with a solid inverted pyramid first, which might make it easier. Okay, good luck and have fun coding these.